start with questions from homeworks. Ava. 26. So tan of pi over 8. Here we're asked to use half angles. I would start by converting the pi over 8 to degrees. When I take 180 and divide it by 8, I get 22.5. You did the wrong section. Now, I want to rewrite 22.5 as a half of a unit circle angle. Well, 22.5 is half of 45. So I go and I look at my half angle identities. So I want to use H3, but I have 3 different versions of H3. None of them are wrong to use, but if I'm looking here, me personally, one of them seems way more convenient than the others to use. So the first one has a plus or minus and a square root over a fraction. Pass on that. That's feels like the most amount of work possible. So it's really between versions 2 and 3. If I'm looking at H3 and I'm looking at versions 2 or 3, which one of them do you suppose that Mr. Kulik would choose? He's picking H2. The reason he's choosing that one is because he wants there to only be one thing in the denominator. He doesn't want any addition or subtraction in the denominator, because worst case scenario, if I have to rationalize the denominator, I don't want to have to do like the foiling and multiplying by conjugate, all that nonsense. I'd rather just have a straight up multiply by some radical and be done with it. Seems like less work to me that way. Ava, does that make sense as to why I'm picking H2? Again, not wrong to do the other ones, just potentially more work. And I am efficient and have a hard enough life. I don't need to make my life any harder on myself than it needs to be, right? So at this point, I go to my unit circle and look up the values for cosine 45 and sine 45, which are, who can tell me? Square root 2 over 2 for both of them. Great. Now, what's the issue? I have fractions inside of fractions, right? How do I take care of that? Well, I just multiply the top and bottom by the denominator in my little fraction. So when I distribute that through, I get 2 minus root 2 over root 2. Feel good so far? I'll multiply the top and bottom by square root 2 to rationalize the denominator. Notice since there's no plus or minus in the or addition or subtraction in the denominator, this is just like a straight, like easy rationalize the denominator thing. There's nothing like complicated going on here. Ava, does that look okay there? And I notice here that everything has a factor of 2 in it. So to reduce that, I'm just going to write this as 2 separate fractions with a common denominator. So the first one, I can reduce the root 2's, and the second one, or the factor of 2, leaving just root 2. The second one, I can reduce both the 2's, leaving just 1. That should be my answer. Worth pointing out to you guys again that these are all checkable. So make sure, well, I'll just use 22.5. So if I do tan of 22.5, that was my starting problem. And then I do square root 2 minus 1. Same thing. Joey. Sure. So hopefully it comes as no surprise that we're going to do tan 15 becomes tan of 30 over 2. I'm going to use the same formula from last time. So 1 minus cosine 30 degrees over sine 30 degrees. If I go to my unit circle and I look up cosine of 30, I get root 3 over 2, and sine 30 is 1/2. Again, fractions inside of fractions, we'll get rid of that the same way. So that's just going to be 2 minus root 3. No rationalizing the denominator necessary because there's no radical down there. That's pretty rad. What'd you guys think? Joe, you okay there? Okay. All right. Yes, sir. 15? Yeah. Sure. Okay. What were the directions here? Half angles, okay? So I'm going to do tan negative 60 over 2. Again, negative 60 is a unit circle angle because negative 60 plus 360 is 300. That's a unit circle angle. So I'm okay there. I'm just going to leave it as negative 60 though for a moment. Just like the previous problems, I'm going to do H2 and I'm going to do that version 2 of it. And here I'm going to go ahead and convert those negative 60s to unit circle angles now. And we'll go to our unit circle. Cosine of 300 is 1/2. Sine of 300 is negative root 3 over 2. Take care of the fractions inside of fractions. So I get 2 minus 1 over negative root 3, or just 1 over negative root 3. And then I can just rationalize my denominator. And I'm all done. Delaney. Are we supposed to do 1 through 10 on the worksheet or 1 through 10 on the 1 through 10 on the problems? I did assign the whole worksheet also, though, so if you've done 1 through 10 on the worksheet, you didn't do extra work.
Oh, okay. But can you do 3? No, yeah, 3 from the worksheet.
Sure. Joe, is that okay?
Yeah.
Okay. I just like double circling back before I finish, before I scoot off to do something else. Okay. Okay. Stop. All right. So let's start here and convert that into just degrees, right? So those cancel out. Let's see, 6 goes into each of those. So that should be negative 15, it looks like. Is that so far so good, Delaney? Okay. So I think the directions want us to use sum and difference identities here. Is that correct? Let's double check. Yep. So I'm going to write that as tan of 30 minus 45. There's lots of possibilities, but I think that's the most obvious of them. Is that what you used?
No, I didn't give it.
Oh, okay. But that's I think the natural one to choose, right? You could have done 60 or 45 minus 60. You could have done like 315 or 300 minus 315. There's like so many you could use, but I mean, like, I'm going to do that one. I'm going to then use SD6, which is the one that kind of governs what's going on there. So that's going to be tan of 30 minus tan of 45 over 1 plus tan 30 times tan 45. I'll go to my unit circle and look up the values for tan 35 and tan 45. Remember, tangent is y over x. So root 2 over 2 divided by root 2 over 2, those just become 1s, right? And in the other fraction, the denominator of 2's can cancel out. So here I have 1 over root 3 minus 1 over 1 plus 1 over root 3. I'm going to multiply the top and bottom by root 3 over root 3 to get rid of the fractions inside of fractions. Is that so far so good, Delaney? Last thing I need to do is rationalize the denominator. Notice there is addition and subtraction going on in my denominator. So to do this, I need to multiply by the conjugate. The conjugate that I need is the same as the denominator, just with the opposite sign in the middle of the two things. So I do that to the top and bottom. Now it's a FOIL problem. So the numerator, I get square root 3 minus 1 squared minus square root 3 squared plus square root 3. The denominator, I notice that this is like a plus b times a minus b. So I know that for my Algebra 2 class, that's a difference of 2 squares. It'll be a squared minus b squared. I'm just doing that to shortcut through the foiling. If you forget that, you can always FOIL it out. You'll end up with the same thing, but that's quicker. So I like to do that. I know the squares cancel the square roots. So in the numerator, I have a negative 3 and a negative 1. So I'm going to have a negative 4. in the denominator, I'm going to have a 3 minus 1, so that's a 2. And then I'm going to have 1 root 3 plus another root 3. That gives me 2 root 3s. And I notice that, hey, everything in there is divisible by 2. So if I break that up into 2 fractions with a common denominator, the first one reduces to -2, and the second one reduces to root 3. And that ought to do it. Does that feel okay there?
Yeah.
It's just a lot of cleanup at the end on that one. Joey? 9. Do I have it already down on one of these other ones? Nope. Okay. And this is using the power reducings, okay? So here, for the power reducings, there's nothing that I need to do to rewrite the angle in any kind of way, other than maybe converting a radian to a degree if I feel like it. So I'm just going straight to power reducing number 3. So that's going to be 1 minus cosine of 2 times 165 over 1 plus cosine 2 times 165. Now 165 times 2 is 330. And if I go to my unit circle, if I do cosine of 330, I get root 3 over 2. Multiply the top and bottom by 2 over 2 to get rid of the fractions inside of fractions. And then we'll multiply by the conjugate, which would be 2 minus root 3. We'll do that to the top and bottom to get rid of the radical in the denominator. So all feeling good, Joey? Okay. So the bottom becomes 4 minus root 3 squared. The top becomes 4 minus 2 root 3 minus 2 root 3 plus root 3 squared. So again, I know the squares cancel with the square roots. So in the top, I have 4 plus 3, that's 7. And the bottom, I have 4 minus 3, that's just going to be 1. And then -2 root 3, and then another -2 root 3 makes -4 root 3s. And since that's all over 1, I can just drop the over 1 part, and that's my answer. Right, because anything over 1 is just itself. So I can just, 7 over 1 is just 7. So 7 root 3, or 7 minus 4 root 3 over 1 is just 7 minus 4 root 3. Ava. So I have a 4 plus 3. And that's where the 7 comes. Does that feel good? I know it's tempting to cross the 3 out when we cancel the radical with the squared. Got to remember to hang on to the number though. Okay. Shall we start chapter 7 then? There's a lot of questions. You guys did a pretty good job. You feel okay about chapter 6 stuff? This should have been fairly straightforward, right? It's mostly just plugging stuff in, getting it to work in the formula, plugging the stuff into the formula, and then grinding out the simplification, right? Nothing too tricky. More or less, the problems are kind of all the same. which is always kind of nice, right? Like we like it when it's all the same. All right. Starting chapter 7. So So, just as a refresher, something we'd have talked about first semester was solving triangles. To solve a triangle, we need to find all the side lengths for that triangle and all of its angle measures, right? You guys remember doing this? For a right triangle, we can use SOHCAHTOA and the Pythagorean theorem, right? Does everybody remember doing this in first semester? Okay. What about for non-right triangles? Can't use SOHCAHTOA, can't use the Pythagorean theorem. We'd still like to be able to do this problem. Well, turns out that we do have two tools. We have what's called the law of sines. I'll abbreviate that as LOS. And the law of cosines. I'll abbreviate that as LOC. We're going to talk about how these work and how to use them to solve triangles. That'll be the bulk of chapter 7. Okay? So the goal in all of chapter 7 is going to be dealing with how to solve these non-right triangles. I want to say again for the record, in a non-right triangle, you cannot do SOHCAHTOA, you cannot do the Pythagorean theorem. Okay? In a non-right triangle, you cannot do SOHCAHTOA, you cannot do the Pythagorean theorem. So let's look at these, look some more about these non-right triangle situations. So to solve a non-right triangle, we're going to need 3 pieces of information to start. One possibility is that you're given 2 angle measures and 1 side length. Everybody's okay with that idea? Now, this can actually cover 2 different scenarios, though. So let me show you what I mean here. So say we have this triangle ABC, and you're told angle A, angle B, and then side BC. If you remember back to geometry, I know that's a long time ago, and you remember your angle congruence theorems, or triangle congruence theorems, I should say, not angle, triangle congruence theorems, they all had like 3-letter abbreviations, right? one of them would have been like angle, angle, side, and the other would have been angle, side, angle. Do you remember how to tell the difference between those two when you're looking at a picture? So you want to look to see whether the side is between the two angles or not. Is this side in between the two angles? No. What side is in between the two angles? AB. This is angle, angle, side, because it's, if we look at it, angle, angle, side, right? If you look around the triangle like a counterclockwise motion, does everybody see that? Versus the other option, which I have a feeling you know where I'm going here, where we have angle, oops, use the color there, angle, side, angle. Ah! What did I just do? There it is. Is everybody okay telling the difference between these two? Okay. Another option, we can have one angle and two sides. Now, there's two ways that, or two different scenarios that this can happen, right? So if I look at the first triangle, what situation would we name that first triangle if I use those same three-letter conventions we've just been using? Side, angle, side. Excellent. And the second one we would give side, side, angle. Does everybody feel good about how we're naming these things? It's going to be critically important that you're able to pick out which one of these scenarios you have, because that's how we decide what to do and what can happen. Okay? So the first number one step is you have to be able to identify what situation we're in so you can tell what you need to do after that. If you can't do this first step of identifying what type of problem you have, doesn't matter what happens afterwards, because it's going to be tough to get it right. So this is step one. We have to be able to do this. And the third situation is just three sides. Well, I mean, gosh, Mr. Kulik, there's only one way that can happen, right? That's just SSS. So far, so good. Okay. We'll do some practice here once we kind of get a little further in like picking these things out, because we're going to do it at the start of every single problem we do, is decide what the situation is that we're looking at so we can accurately and correctly do the problem. But this is what I think we need to start with, is just making sure that we are clear as to like step one is being able to identify the situation. Right? Okay. So if we have a angle, angle, side, an angle, side, angle, or a side, side, angle, that calls for using law of sines. And if we have side angle side or side side side, we're going to be using law of cosines. That would be something I would put on my half sheet of notes for sure, because I'd want to make sure I know when to use which formula. Okay. So let's look at the law of sines here. In the honors course, we had derived this formula. In this course, I'm just going to write the formula down, state it, and we're going to practice using it. So we're not going to go and derive how we get this. If you're curious about that, the lessons in the notes go through that in pretty good detail. Actually, I'm going to add in. I'm going to put an angle there just to double reinforce that we only do sine on an angle measure as opposed to a side length. I still see that mistake get made here and there from students, so we should be careful. Now, when you're actually doing the problem, you're only ever going to use like two of the ratios, right? So when you're doing a problem, you're just going to be setting two of those fractions equal to each other. It doesn't matter which two because they're all equal. You just have to look at the information you have and make a decision about which two you need to use. Is everybody okay with that idea? All right, let's look at an example, or some examples here. Actually, I'm going to do this. Okay. So we're asked to solve the triangle. We're told angle A is 32, 32 degrees, angle B is 73 degrees, and side C is 13 inches. My first step is going to be draw and label a picture, because I want the picture to decide which situation I'm in, right? Now, every time I draw a triangle, I draw nothing to scale. I just draw it and label it. If you want to try to draw things to scale, that's fine. I never bother with it. I just kind of draw the same shaped triangle every single time because it doesn't really matter to me. Now, I've labeled my triangle angles A, B, C. Now I need to name the side lengths. When I name the angles, if I'm doing that first, I can name them any way I want, right? Doesn't matter which corner I make A, B, or C. But once I've named it, the corner, the names of the sides absolutely matter. Okay? So if I've named this angle A, the side opposite angle A must be side A. If I've named this angle B, the side opposite angle B must be side B. And likewise, if this is C, the side opposite C must be side C. Is everybody okay with that naming convention? Critically important that you're able to draw and correctly label a triangle. If you can't do that, you're going to have things in the wrong place and everything's going to get screwed up and it's not going to work. Okay? Do we feel comfortable doing this? We did this first semester also, right? Talked about this naming convention, I think. Yes? Okay. So I'm going to just kind of clean this up now a little bit. All right. So I've drawn and labeled my triangle. I'm going to add in the things that we know. Does everybody feel okay with how I've added the measurements? Now I'm going to ask myself, which situation is this? Is this angle, side, angle, 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 side, side, angle, side, 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 angle, side, side, side? Which one of the 6 possibilities is this? This is what? Not side, angle, side. Angle, side, angle, right? Because we have 2 angles and 1 side. So this tells me that I need to be using law of sines. Is everybody okay here? Now notice in the situation where I have 2 angles, I can solve one part of the triangle basically for free without a lot of effort, right? What can I find immediately with what's been given? It's not side A. Angle C. Great. How can I find angle C right away? Triangle has only 180 degrees to it. So C must be 180 minus the 32 minus the 73. So that's 75 degrees. Add that there. I'm actually going to go back and do some color coding here. So far, so good. So that's easy. That's for free. Anytime I have 2 angles, as soon as I have 2 angles, I can find the third one, right? Whether I'm given 2 to start with, or my first step found a second angle, as soon as I have 2 angles, I can get the third one for free, right? So in any of these solving problems, I'm at most going to be looking for 2 of the 3 remaining pieces, right? There's 6 things to solve, right? 3 sides and 3 angles. I'm going to always be given 3 of them. One of them, the third angle, I'm always going to get for free, basically. So it's really just finding the remaining 2 that is going to require some mathematics from me. So far, so good. Now I'm going to apply the law of sines. Let's go back and look at the formula. So when I'm looking at my law of sines, I am looking for a situation where I have the angle and the side opposite it. So that's what I want to start with. I want to go back and look at my picture and find the angle that I know and the side that's opposite of that angle that I also know. In this picture, that should be A, B, or C. C, right? Because I know angle C and I know side C. That's the only situation that I know both. Does everybody feel good there? So I'm going to start there. I'm going to start sine 75 over 13 equals, and then I'm going to choose. I'm either going to find side A or side B. In the case of an angle side angle problem, it does not matter which one I find first. So let's say for the sake of argument, I look for the side A for alphabetical. Is everybody okay with how I've set up the law of sines? What type of equation is this that I have where I have one fraction equal to another fraction? What do we call that? A proportion. How do we solve a proportion? Cross multiply. Remember, cross multiply is a solving technique, not a way to multiply fractions. So to solve a proportion, we cross multiply. So we have A times sine 75 equals 13 times sine 32. The next step would be to divide by sine 75 to get the A by itself. Does everybody feel okay with what I've done here? At this point, it's now calculator time. So I'm going to pull out my calculator. What's the first thing I'm going to do? I haven't used my calculator in a while. Check the mode. What mode should my calculator be in? Degrees, because the angles in this problem are all in degrees. So my calculator is already set to degree mode. That's handy. So I'm going to start by doing alpha and y equals. That opens up the fraction menu. I'm going to select option 1. That allows me to type the problem in exactly like it looks like on my sheet of paper. That way I don't have to worry about any parentheses issues. Oops.
What'd you do to get the fraction part?
Alpha y equals, and then option 1. I just pressed enter. So that gives me about 7.13. Everybody okay to there? Last option is to find side B. Can I use the Pythagorean theorem to do that? I have 2 of the 3 sides. No! Why not? It's not a right triangle. Again, I'm going to try to trick you guys every day into using a non-right triangle thing to solve these right triangle things and then yell at you for it. But hopefully that sticks then, because you've gotten yelled at so many times. You're like, okay, I got it. Mr. Kulik's going crazy here. Okay. So now I'm literally going to repeat the same process, except instead of using sine 32 in my formula, I'm going to be using the angle B sine 73. Is everybody okay with that idea? So again, I'm going to do sine 75 over 13 equals, and now I'm going to do sine of angle B, which was 73, over little b. We cross multiply, Yes.
Do you use sine 32 over sin 45?
So that's a great question. So Joey asked, instead of using sine 75 over 13, could I use sine 32 over 7.13? The answer is yes. The reason I would not is the 7.3 is rounded, and I'm the least sure of that answer. If I made a mistake somehow in solving part A, and I use that answer to then solve for part C, it's going to end up giving me the wrong answer in addition. I'm much more positive that the 75 is right because it's like just simple arithmetic. But the answer to your question is yes, you could do that there instead. I just choose not to because I feel it's safer because one, there's no rounding, and two, I'm pretty positive that I did the 180 minus the other two angles. So it's calculator time now. Again, I'm just going to do second y equals, and I'm just going to update the 32 to 73 and save myself all the buttons. So that's 1287. Oops. And then my last step is to do that pseudo check that we talked about in first semester. So what I want to do is I want to check across from my biggest side is my biggest angle. Yup. And then my middle side should be the middle angle. Yup. And then the smallest side should be the smallest angle. Yup. That's not perfect, but it's a pretty good check. It doesn't guarantee you that your answer is correct, like if you just transpose two numbers. Like if I wrote 1278 instead of 1287 or something, like it's not going to catch that. But if you set something up wrong and you do something wildly wrong, it'll catch that kind of thing. Or if you put something in the wrong spot, which is also a common mistake, should catch that. Like if I had put the 7.13 where B is, that should get caught. Wait, what's up?
We need to show that check.
No, that's just like for you guys. Just like when I showed you on the calculator how to like, I can do tan of 15 and then my answer and just compare the two and make sure that they're the same. Okay. Never have to show that. I'm just telling you that like, yes, okay. Yes. And again, it's not a perfect guarantee, but it's pretty good. It catches a lot of silly things that we might do. All right, let's do another example here. Oops. Yes, sir. Yes. So let's say new example. Angle P is 43, angle Q is 80, and side Q is 7.3. First step is to draw and label our picture. What are the three letters we should use? PQR is what I would use, right? R is the next letter after Q. Does it really matter what letter I use? Not really, but like, come on, it's just the alphabet, guys. And then I have to label my side lengths. So remember that side P should be opposite angle P. Side Q should be opposite angle Q. Side R should be opposite angle R. And then I'm going to label So which situation is this? Angle, side is correct. Very good. Does everybody feel pretty good so far? Okay. What can I get for free, basically, right away? Angle R. How do I find angle R? Great. 180 minus 80 minus 43, which comes out to be 57. So far, so good. Okay. Let's set up our law of sines then. Which ratio should I start with? Sine of what over what? Great. Sine of 80 over 73, because that's the only pair of angle and side that I know both of. Now, does it matter which side I solve for next? RP? It does not. I like alphabetical, so I'm going to solve for P first. And then we cross multiply and divide. I'm going to just combine that all into one step. Is everybody okay with me doing the cross multiplication and division all in one step? I type this into my calculator, and I get about 5.06. Is that okay? Again, I skipped typing it in my calculator. You guys are okay doing that, though, I think, at this stage, right? We've used the calculator a lot. We should feel pretty comfortable. Okay. And now we just need to solve for side R. So again, I'm going to start with the same ratio that I did last time. Sine 80 over 7.3. As Joey mentioned, we could use sine 43 over 5.06 instead. I would not, but you can. It's not wrong. And then we have this over angle R, which was 57, over side R. And again, we cross multiply and divide. And that gives us 6.22-ish. And last thing I'm going to do is just check my ratios and make sure that smallest across from smallest, middle across from middle, biggest across from biggest. That all looks pretty good to me. I'd say we're all right. Does everybody feel good so far? Okay. All right. You know what? I'm going to just call a little bit of an audible. I'm going to skip section 7.2 for right now. We'll circle back to it. I want to do 7.3 first and come back and do 7.2. Is everybody okay with that? So the agenda on the week is going to be a little bit messed up, but we're just switching the days we're doing those two things. 7.2 is the hardest section in the chapter, so I just think that having a day to do some law of sines and law of cosines homework first will be beneficial. So I'm going to just take a little detour there. So law of cosines says Oh boy. So law of cosines has like 3 versions, depending on kind of which side. But they're just the same version, just like the labels have been changed, right? What does this formula kind of look like? It looks like the Pythagorean theorem, right? If I look at just this part, it looks like, a squared plus b squared equals c squared. And we have just like this extra correction factor then at the end. Is that, you kind of see that? And that is ostensibly what's going on. If we were to do the derivation of this, we're going to end up building it off of the Pythagorean theorem. We're not going to do that in this course, but I'm just going to state the formula and do some examples. But if you were to do that, that's the way that it would be done. All right. So let's just do an example or do some examples. So if we're asked to solve the triangle where A equals 34 degrees, angle A equals 34 degrees, side B is 14 and side C is 17. Again, first step is to draw and label a picture. So ABC, 34 degrees, side A, side B, side C. B is 14, C is 17. What do we got here? Which situation? This is side angle side, which tells us then we need the law of cosines here. So, using the law of cosines, I'm going to be solving, I have angle A, I have side B, and side C. I need this formula. Oh my gosh, guys, look at this. That's supposed to be angle C on the bottom one. Please change that if you wrote it down. Yikes! It's a big boo-boo, Mr. Gulick. I know, you're better than that. I'll do better. All right. So we have A squared equals 14 squared plus 17 squared minus 2 times 14 times 17 times cosine of 34 degrees. Please, for the love of God, when you're typing this in your calculator, do it all in one line. Okay? Don't do like 14 squared and then 17 squared and then 2 times 14 times 17 and then write that all down, because what happens so often is people subtract, like add 14 squared and 17 squared and then subtract the 2 times 14 times 17, and it's no! Because they haven't done the cosine of 34 yet. Happens all the time. Just type this into one line on your calculator. Just like it looks like on your sheet of paper. Mr. Kulik, that third side can't possibly be 90 long. Oh, yeah, because it's a squared. We got to square root it. Yeah, good job. So I'll just do square root of that answer, and that's about 9.5. Oh, I forgot the number now. 0.4. That was 9.51. That was. Now we have to be very careful. The choice of B and C matters here. Okay? The choice matters. We need the smaller of the two angles. So if between B and C, which one is smaller? Oh my God, Mr. Kulik, you did it again here. Look at this, you dumbo. That's supposed to be B and that's supposed to be C. All right, anyways, which one is smaller? Did I? Oh my gosh, this is just like all, okay, it is. There we go, 17, 14. Fortunately, the other one, it doesn't matter, but B is smaller. How do I know that? Because the side length is smaller, right? Everybody's okay with that? Okay, so angle B in this case, right? Now, I could use the law of cosines again to do this, but I would rather use the law of sines. Because now what I have is I know angle A and I know side A. Okay? It'll be easier than using the law of cosines again, I promise.
So basically you could, but it'd be easier to use.
Yeah. You could, but it's kind of gross. The algebra's worse, way worse. Yes. Uh-huh. So we're going to do sine of 34 over 9.52 equals sine of angle B over 14. So far, so good. I'm going to cross multiply and divide. So I have sine of angle B equals 14 times sine 34 over 9.52. But how do I get rid of that sine in front of the angle B? What cancels that out? Sine inverse. Very good. So we do like a sine inverse to both sides. So those like cancel out. And now it's calculator time. Now, please, when you're doing this, use the fraction command. Again, that's alpha y equals in option 1. And then please use the ants command and use that full decimal, right? So second and negative sign is the ants command. That just means the last answer in your calculator is going to be inserted there. The accuracy will matter a little bit on these. You want to make sure your angles will add up to 180. So I do that, I get 55.44. How am I going to find angle C? Yeah, good job. So we know we have the 34, and we know we have that 55.44. So we get 90.56. You guys feel okay? Okay. Again, the big takeaway here is the law of cosines. We have to be careful when we're finding these angles. The other situation we use law of cosines is the side situation, right? Now, this situation requires a little bit extra check at the beginning. Before I draw and label a triangle, I need to check if the triangle is even possible at all. Do you guys remember how to check if a triangle is possible from leg lengths or from side lengths, from geometry? Leg plus leg must be greater than the hypotenuse. That's our check. Mary? Certainly. So for our problem, 5 plus 8, is that greater than 10? You betcha. So this problem is possible. If it fails that check, you can just write no triangle possible, and you're done. There's nothing else to do. Any side situation requires you to start with that check, though. Only side situation requires this check. Is everybody okay with the check? It's an easy check to do, but you have to remember to do it. Because you don't need to do it every time, because you're not given 3 side lengths every time. Okay. Now I'm going to draw and label my picture now that I know that it actually makes a triangle. Now again, we have enough information to solve for angle P, angle Q, and angle R. All of those I could find right now, correct? Everybody agree? Guess what? It matters, again, which angle we start with. In the side situation, we need to do the biggest angle first. After we do 7-2, I'll circle back and talk to you guys about why we're doing these things in this specific order. It'll make a lot more sense. But that's a hard section. I just want to have a kind of a day where I can do that by itself because it's a lot. And it'll help to have done some of this stuff as practice first. Okay, so which angle is going to be the biggest, P, Q, or R? R, how can you tell? Because the side length is the biggest, right? It's 10. Everybody's okay? All right. So I can say that R squared plus P squared plus Q squared minus 2PQ cosine angle R is equal to each other. Now, before I fill the numbers in, I'm going to get the angle R by itself. Everybody's okay with that plan? And then I'm going to plug the numbers in after I've already done the algebra. I'm doing it this way because I find that it'll be less likely for students to make an algebraic mistake. So first thing I want to do is I'm going to subtract the P squared over to the other side. And then we'll subtract the Q squared over to the other side. And now we have to divide by negative 2PQR, because all of that stuff is being multiplied to the cosine, right? So to move it over, I have to divide it. And then to get rid of that cosine, we use cosine inverse. And now I'll fill these guys in, the numbers. P was, which one was P? 5. And once again, students, for all that is holy, do this in one line on your calculator. Use the fraction command and just do it in one line on your calculator. The amount of mistakes I see made by students like trying to chunk this when it's wholly unnecessary drives me bonkers because I have the right thing written down and not get the right answer because they couldn't get into their calculator. Don't chunk it. Cosine inverse, fraction command, 10 squared minus 5 squared minus 8 squared over negative 2 times 5 times 8. Gives me 97. Point something, I forgot the point. 9. Now, if we put this in, what we have here is an angle or a side angle side situation, right? And we're finding the next angle of the two. In the side angle side situation, when I have to solve one of the two remaining angles, which one do I find first? The smallest. So again, it matters which angle you use or which angle you look for. And to do this, I'm going to do a law of sines, just like we've done before. So I cross multiply and divide and do the sine inverse. And when I type that in my calculator, I get about 29.69. And the last one, angle Q, is easy because it's going to just be 180 minus the 9790 minus the 2969. And that comes out to be about 5241. So for next time, I'd like you guys to do 1 through 4 and then 15 to 22.
That's chapter 7.
This is chapter 7, yes. Yes.
And all these are due this Sunday.
This would go into Sunday's problem set as well, because we'll meet again on Thursday to talk about these ones. What we do on Thursday would go into the following week's problem set.
All right.
So for Sunday, we got this guy, and then we have chapter 6, 1 through 10, and then 23 to 26, and then worksheet 1. That will be Sunday stuff that I'll be looking for. This is chapter 7, yeah. Yep, because we meet again on Wednesday or Thursday to talk about this chapter 7 stuff.
Yeah.
Stuff from Thursday, that would not be due on Sunday.
Oh, okay.
So when we talk about the next stuff on Thursday, that's not part of Sundays. That would be the following Sundays.
Okay. And do you know when the test will be?
Probably next weekish.
End of the week next week?
Yeah, probably end of the week next week
Okay.
is what I'm kind of eyeballing.
Okay.
Okay. How do you guys feel so far? Was this okay today? It's not too bad, right?
Yeah.
It's kind of review. I think you might have done this possibly if you took honors algebra or honors geometry.
Yeah, I did this.
Okay. Yeah, you might have done that there a little bit. Sure. The hard section is 7-2. Because which situation haven't we talked about yet? So we did angle, side, angle, 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 side, side, angle, side, 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 side.
Oh, yeah.
We haven't done SSA, right?
Oh, yeah.
And that one's a bear, because if you remember back from geometry, that is not a triangle congruence theorem, because that does not guarantee triangle congruence. Weird stuff can happen. That one's takes a little bit to get through.
Okay.